Hello, this is Ms. DB. In this video, we are going to look at how to do a couple of the problems from the 12.4 compositions of transformations. So a composition of transformations is when one transformation is followed by another. You could even do more than two. There's a special one called a glide reflection, which is the composition of a translation and then a reflection. So there's that example there. And then example B here is when they took a triangle and they first rotated about the origin and then they reflected that transformation across the y-axis. So more than one thing can happen at a time, and do them in the order that they tell you to. And I have on here all of the rules, so you can go back and look those up for reflections, translations, and rotations. A composition of two isometries is an isometry, so each time that you transform the figure, it should look the same. It should just be changed in its location, but the size and shape of the figure should remain. The triangle or the quadrilateral should not get any larger or smaller or skewed. So here's the rules again, and then what your job for this worksheet is going to be is to draw the transformations. There'll be two for each of these. In number one, you first are going to draw the pre-image, then rotate that 180 degrees about the origin, and then take that second figure, that transformed figure, and reflect it across the x-axis. Remember, the x-axis is the horizontal. And then for number two, you take a triangle and first you reflect it across the y-axis, that's the vertical, and then translate it along a vector. For three, you are going to, this one's a quadrilateral, so it'll have 4 points. First, rotate it 180 degrees and then translate it. Notice that when you translate it, the y component is negative, so it'll be going down 3. And then in number 4, you're going to reflect it twice, once across the x-axis and then across the line y equals x, which is this diagonal line. Now, if you printed your worksheets, you can do these by hand, but be careful. Use a pencil. You might have to erase, and make sure you label your first transformation with the same letters. Each vertex should be labeled with the same letters, but with an apostrophe after it. So A prime, B prime, C prime. After your second transformation, you use those same letters, but with two apostrophes after them to mean A double prime, B double prime, and so on. All right, so we are going to do number 2. So I have a Sketchpad file. It's basically just 4 pages with each of the 4 problems pasted in. You can use that to graph. I highly recommend using Sketchpad to do these because it eliminates, some of the error possibilities as long as you put the points in correctly. You can also use the transform menu if you have learned how to, there's directions, there's a video about how to reflect, translate, and rotate using the transform menus. So you have 2 options in Sketchpad. All right, so I'm going to begin with putting my coordinates for QRS onto my coordinate system. R is 4, -2, and S is 1, -3. And now I am going to label these points. So Q is 2, 1, but it automatically uses A when you start a new file. So I'm going to double click to change that. R is at 4, -2, so this is R. Remember to use capital letters to name your vertices always, not lowercase. And then we have S for that point. Now I'll connect those with segments. And I have my pre-image. Now I need to reflect this across the y-axis, so it's going to end up over here. So I know that that's where it's going to end up. So I look back at the rules for reflections. The rules for reflecting across the y-axis is you take the opposite of the x-coordinate and the y-coordinate stays the same. So I'm going to first find out what each of these would be. So for Q prime, that's after the reflection, I am going to change my x-coordinate to the opposite and leave the y-coordinate the same. Same thing for r prime. I change the x-coordinate, and for the y-coordinate you take the opposite. So, wait, I did that backwards. You switch the x-coordinate and leave the y-coordinate the same. If you ever have a negative and you need to take the opposite of it, it would be positive. But in this case, all of my x-coordinates were positive, so they will all become negative. And then this would be -1, -3. So I have labeled those, and now I'm ready to plot those. Whoops, cancel, let's plot points. So my first point would be -2, 1. My second point would be -4, -2. And my third point is -1, -3. And now you want to label these. So this point up here is Q prime. So Q with an apostrophe after it, capital Q with an apostrophe after it. This point here is R prime. And this point down here is S prime. And I will connect those with line segments. And you can see that that does indeed appear to have been reflected over the y-axis. Same shape, same size, just a reflection. Oops. All right, so then the next thing I have to do is translate this along the vector with the horizontal component 1 and the vertical component 3. So these were after reflection. And now I'm going to write what my points would be after the translation. So Q double prime, because Q has been transformed twice, it says to take your x-coordinate, which is -2, because we're using Q prime, R prime, S prime, to then transform that triangle. And we are going to add 1 for the horizontal component, and my y-coordinate was 1, and I add 3 for the vertical component. And then I simplify that, and -2 plus 1 is -1, and 1 plus 3 is 4. Okay, so my first point will be at -1, 4. Let's find out what the next points are. So R prime x coordinate was -4, and I need to add 1 for the horizontal component, and its y coordinate was -2, and I need to add 3. And I simplify those, and I get -3, 1. And then for S double prime, I had the point -1, 3, but I need to take and add 1 to the horizontal component, and I need to add 3 for the vertical component, and that simplifies to 0, 0. All right, so this translation should move this triangle, QRS, it should move that triangle up, well, first right 1 and up 3. I'm going to change this to a different color just to make it easier to see the transformations. So color, I'll change it to green. So the green one was after the reflection. All right, so my Q double prime is -1, 4. Let's check. Yep, that looks like it moved it right 1 and up 3. And then -3, 1. Yep, and then 0, 0. And 0, 0 is on top of that 0, 0. So now I'm going to label these. This was my Q double prime. This was my R double prime with 2 apostrophes. And this is my S double prime. And if I connect these, this triangle should be the same shape and size as my other two because it's an isometry. So this would be my final answer here. This red one. So the blue was your pre-image, your green was your first image, and your red is your second image, which is after it has been reflected and translated. So then this is done now. All right, so there is 4 of those to do. I just did one for you, so you can follow along with those steps to learn how to do it. Then there's another theorem here that says that we have a composition of 2 reflections across 2 parallel lines is equivalent to a translation. So if you reflect the blue, I think we're starting with the blue, reflect it over this line to get the green, and then reflect the green figure over this line, then that is equal to a translation from the blue to the red. And there's another part that the length of the translation vector is twice the distance between the lines. Here's another interesting thing. The composition of 2 reflections across 2 intersecting lines is the same exact thing as a rotation. The center of the rotation would be that intersection, and the angle of rotation is twice the measure of the angle formed by the lines. So you could do a lot more with composition of functions, and you may in your future in a more advanced geometry class. We're not going to do a ton more work with them. So any translation or rotation is equivalent to a composition of 2 reflections. This is interesting. You could recreate any translation or any rotation with 2 reflections. So here's a few questions that ask you to kind of make sense of those theorems up above, to read carefully and fill in the blanks. And then at the very end, there's a chess game. A knight can move in the shape of the letter L, and the piece moves 2 places horizontally or vertically, and then it turns 90 degrees in either direction, moves 1 more space. So you're going to describe the knight's move as a composition of transformations. What does it do first? What does it do second? And then figure out how many possible moves are there for the knight for the next move. All right, and then you can, number 10 here we go, got split. There's an error analysis. Pick which one is incorrect and tell what the error is. And then there's a sometimes, always, or never true part down here. Just a few of those. All right, thanks a lot and have a great day.